excited about this talk. Well, actually, until just a couple minutes ago. Somebody came up, one of you came up to me and asked me, I mean, a very reasonable question, I guess. Is Bill Nye your real name? And I said, well, it's William Nye. And he said, well, why did you change it? I got a little concerned. I kid. It's going to be fabulous. Let's bring up here. So tip of the hat to Steve. All right. Oh, you say it's on. Are we on? We on? We're on? Yeah. This is the Earth. I got to say, it's actually a picture of the Earth. If we had the Earth here, I don't think it would even fit in this room. But there's a picture of the Earth in the background. In the foreground is the moon. And if you, well, it's a picture of the moon. If you showed this picture to my father when he was your age, he would have thought you were crazy. There's no way to get such a picture. But you can if you have a spacecraft that you can guide out to the moon, have it not crash, have it send pictures back, and show the Earth to everybody. The other thing that would be, I think, incredible at first to my father, you guys can't really see it, it was a great picture. You people, it's fabulous, believe me. Sorry, guys. And a woman doing the signing. What's her name? Mariko. Thank you, Mariko. A hand from Mariko. I don't know if you can all see this dress on some very cool shoes. Very cool. The other thing that this picture would throw my father off and make you think you were kidding him was the Earth has too many clouds. In those days, people at his age would have expected the Earth to look like a globe, like a classroom globe with no clouds at all. There are certain globes nowadays with clouds, but not in his time. The globe was it was a map. So things have changed in your lifetime a tremendous amount. What we now take for granted used to be incredible, and I hope what you find incredible will one day be taken for granted. My father, with all this, let me say, was very open-minded, and he was of a scientific bent. This is my dad, actually a picture of my dad. Woo! He's quite the rock hammer, so he's got a rock hammer. Used for hammering rocks. And those who've never seen them, I also pointed out the rocks themselves. So my dad was an amateur geologist. He called himself an Nye boy scientist.
Turn up the mic!
Someone in the back has asked the microphone to be louder, so I leave it to the peoples to pick the right volume. But then I'm starting to get a little bit of the reverb. Well, you guys, you decide. And the guy who called out is, you know, he didn't get here on time. But thank you for coming. I don't know who the people in blue are, but you look great. Whoever you are, I see you around. Anyway, my dad was in law school, and for some reason he didn't like it. Go figure. So we had this idea, which at the time was quite unusual. In 1940, it was an unusual idea. He thought he'd take a year off. And so he got this job working for the Navy on Wake Island. And I don't know if you know where Wake Island is. It's out in the middle of the Pacific Ocean, like nowhere. You go to Hawaii, and then you go about that far again, and you're on this little thing called Wake Island. And it's, as small as it is big enough to build an airstrip. So this is a picture of Wake Island taken in the summer of 1941. And they had some huts. And if you wanted to fly from the mainland of the U.S., you'd stop in Hawaii, and then you'd stop on Wake, and then you'd go from there to Shanghai or some other exotic place in China, or in Indonesia, a place like that. And my dad, being the college kid, he was the quartermaster, so he was responsible for refueling these planes, these Boeing flying Clippers. And it's interesting to note that planes landing on water, you see in the movies, it looks really cool here. The plane lands on the water. Anybody fly a seaplane here, probably the Air Force ROTC or something, way to go. Anyway, it looks great in the movies, but it's actually quite hard on a plane. And not a single one of these planes survived World War II. There's pieces of them, but they all kind of are a little bit fragile. When you're on a plane and it's falling apart, you know, that's not good. But as far as anybody in my family can tell, my dad described his job to us later on, and he said it was the greatest summer ever. You know, he just worked all day in his swimsuit, and it was fun. As near as we can tell, that's my dad. That's Dad working. Those are your tax dollars. But if you know anything about 1941, it was cool, I guess, in the summer in Wake Island. But then on December 7th, 1941, Wake Island was bombed by the Japanese military as part of their strategy to take over the Pacific Ocean. Nowadays, they call it the Pacific Rim. And so this was a stressful thing. They defended the island for a couple of weeks. They shot back. They shot down a whole bunch of planes. But this is the Evening Star newspaper, which back when most cities had two newspapers. Now the Evening Star is the Washington Times. But it is interesting to note that even then, here's the world ending, okay? Pearl Harbor's bombed. All these battleships are sunk. The United States has been taken by surprise, not ready, very much akin to the feeling of 9/11 we had 10 years ago. But even then, on the front page of the Evening Star, they remind you 14 shopping days. And it shows you the complexity, like this happened so fast. People were taken so off guard. It's very much akin to the feeling we had in the U.S. In September 11, 2001. People were just shocked. But the paper was going to print anyway, and 14 shopping days was on there, so they left it. World ending and 14 shopping days. So my mom, the reason my dad went off, my grandfather, my mother's father, would not let my mom get married. And the family story is to my father, until she was graduated from college. So this is before Facebook, before Twitter. Yeah, I know. Yeah, somebody said, what? You might ask, what did you do all day? Yeah. Did you look in the same direction you were walking? Wow. Grown-up point of view. That's the old man point of view. Anyway, my mom, this is the story was happened by the dumb luck of the universe to be graduated in the spring of 1942. So she was graduated from something called Goucher College, which back when they had such things was the sister school to Johns Hopkins. Now it's its own liberal arts university, University College. Anyway, the president of Goucher, the woman, was the first cousin of the Secretary of Defense. So the story goes, he asked his cousin, Stimson, Secretary of War, sorry, back when they called it the Secretary of War. But no, it's not war, it's defense, okay? All right? To many people, it seems like war, but it changed the name. Anyway, do you have any women that can come work on this thing? I can't tell you what it is. So my mom spent World War II in the Navy. She was a cryptographer because the family story is she was good at math and science. So weird, yeah. So she worked on this thing called the Enigma code in World War II. And understand, my dad had disappeared. These guys on Wake Island were captured and taken away by the Japanese Navy, and no one knew what happened to them. There was no internet. There was no global communication by satellites. There was no such thing. So my mom people didn't know where my father was for quite a while. But just being, oh, welcome. Taking over from Rico. Who are you? Ashley, taking over. Way to go. Hey, wait a second. You got the same shoes. Whoa. I know to many of you that's proof of the paranormal. Whoa. Anyway, look, you guys, I don't mean to be, with all due respect to all the other women who were in the Navy and worked on the Naval Code and were photographed this morning in Washington, D.C. Really, who's got the best legs? I don't mean to be, with all due. So she had apparently been up all night. They were worked on shift time. They worked on 4-hour watches. And the other people showed up dressed for the cool weather. That's the story. Anyway, my dad lived through this thing. They were in prison camp for longer than anybody else from the U.S., 44 months. And he came back in the end of the summer of 1941, and they got married right away that Christmas. And you know, that's what people did back then. Only my father had been in prison camp with no electricity, or hardly any. And so he had very dark skies at night. And they had no watches, no clocks. The Japanese military had confiscated all their jewelry and their wristwatches and stuff. So my father became fascinated with sundials and astronomy. My father could tell you 50 constellations. How many traditional constellations? Anybody? 80 some odd is pretty good. Can you narrow it down? 88, yeah, same as, way to go, blue shirt person. 88 constellations, but a lot of those are in the southern hemisphere, so to be able to do 50 is pretty good. Anyway, so my dad, apparently, the family myth is he would stick a shovel handle in the dirt and watch the shadow, and when it was shortest, that would be noon, or solar noon, and then it's time to eat lunch. And they would tell the guards, you know, hey, look, really, enough. Okay. That's the story. And he got back and started taking pictures of sundials. He invented this little sundial he called the sand dial. And he wrote a book about sundials. He was given a lifetime membership in the North American Sundial Society. We had lunch. I had lunch with an accounting major, and you know how crazy those parties are. You get with the accountants. This is wild. Well, let me tell you something. You're with the sundial people. It is crazy. They all stand around. Watch the shadow. It's moving. I'm sorry. Look. It's moving. So, I grew up with the sundial, and you reach a point in life where sort of everything that sticks up really should be converted to a sundial. Fire hydrant, lamp posts, telephone poles, well, I mean, let alone radio antennas on cars. I mean, just, you know, whatever. And so I would say that I grew out of this, but I was on the East Coast at the beach recently, and I had a pizza box. The calculations are not that hard when you have an Excel. If you have a machine, a computer that can do Excel, it's not that it's a tangent times a tangent. You got to have your latitude. Nowadays, you can get your latitude, you know, to 8 significant digits. Anyway, the two curves are hyperbole, and the sun will never go up, or the little dot will never go above or below that, and the arrow lines are by the horizontal. I could go on. Anything that's not on the surface of the dial that is not used for telling time is called its furniture. So one of the artists in the family embellished the pizza box with some furniture. Anyway, of course it keeps very good time, but you'll find that sun time isn't exactly the same as clock time. And that difference has changed the world. When people were able to reckon time extremely accurately, it has changed the world. Everybody's here, as I'm sure, has been driven around in a car with global positioning. You all have cell phones that can tell you your latitude and longitude within a few meters. And all that is possible because we have spacecraft that are coordinated with clocks to extraordinary accuracy. Anyway, my father wrote articles about sundials, a book about sundials, and he proposed one monograph that was printed in the Evening Star that really, the Washington Monument should be turned into a giant sundial. And what we would have, see, is out there on the National Mall, there would be big plinths. For those of you who play Scrabble, a fabulous word, only one vowel. A plinth is the rock you put your Wolverine statue in. That's the plinth. It doesn't have to be a Wolverine, it could be any statue. It goes on the plinth. It'd be something else if you had a special word just for Wolverine. That would be something. Anyway, these big rocks would be out on the National Mall, and then we could prevent terrorists or whatever from driving up and trying to crack the Washington Monument. I mean, unless you had an earthquake or something. Well, that'll never happen. There you go. Is that proof of the paranormal? So another problem with this Washington Monument sundial. This time of year, it's really good. You can walk along with the shadow. It goes about this fast. In the winter time, when the sun is low in the sky, the shadow extends very far to the north, and so we're going to have to move the White House a few blocks. But I think, you know, if you're into sundials, it's just something you got to do. It's a collateral cost. Anyway, in this room, this is pretty good. This is pretty good because of the lights in this room. I want you all, those of you who can see it, really, this is really interesting. They'll tell you about it. They'll tell you about it, really. If you look at the base of the Washington Monument, where the cement apron is, I think you will see that the shadow is gray. Yes, Bill, we see the shadow is gray. Thank you. No, really. Look close at the shadow on the light-colored pavement, and I think you'll see that the shadow is ever so slightly light blue. Now, this light blue color, there was no English word for this, so I was forced to make one up. It's cirrulescence. Tinge of blue. Because this will reassure you, I know there are probably professors of English here and so on. There is a real word, viridescence, which is a tinge of green. But so far, we did not have cirrulescence with a tinge of blue. But we got it now. If you have never, see, everybody can tell the difference between room light and daylight. Everybody, who's able-bodied, everybody can tell the difference between room light and daylight. But most of us cannot tell you why they look different. Most of us cannot put our fingers on it. And one of the big reasons is the Earth's sky transmits all this extra blue light. You know, next time you are on the moon, notice that the shadows are just stark. They're just black. There is no gray area. No, if I may, twilight zone. They're just stark. But on the Earth, the shadows are not stark black. They are gray, or light blue, or cirrulescent, because the Earth's sky adds all this blue color. All right, so this is interesting. My father was a photographer, did this and that, took an interest in this stuff. But now we take our story from the National Mall in Washington, D.C. in North America to Mars. So this picture is from the Viking lander, which is in 1976, back in the disco era, or if you will, the first disco era. I know many of you have chosen to relive that. I got to tell you, careful. I mean, really, leisure suits, Ford Pinto, really, you guys, do not go embracing the whole disco thing. With that said, this is one of the coolest things humans have ever done. Landed a spacecraft on another world. And when you look at this picture, I hope you can get a sense that Mars is the place. I mean, if you were dressed properly, you could walk around. You could have a picnic. You know, if you go there, it's like a camping trip. You want some food and water, and it's special things. You have to take something to breathe, because they don't have anything for us, if there are any of them. They're not set up for the human visitor yet. You would suffocate in a few moments. But that aside, it is an astonishing place. Now, I was at a meeting, actually a reunion, a gathering of guys who worked on this, people who worked on this a year ago in November. And they were all reminiscing about this picture. This picture went around the world. New York Times, Papua New Guinea Gazette, or whatever it is, the Norwegian Chronicle, and went everywhere. And then there was people got to looking at the picture carefully, and they looked especially at the shadows. And apparently they remarked to each other something like, "Huh, it really doesn't look right. The shadows shouldn't be blue like that." And one guy says to the other, "What do you mean? The sky is blue." I'm not sure the sky is blue either." "Well, it's a planet." "I know, but it's another planet." "Oh, it was like a day and a half. This is NASA, okay? This is, the space program." They realize the sky is really this color. What is that color? That is taupe. Yes. Salmon. Burnt orange. Ecru, yeah. It's, it's where, if you ever go to a department store where they sell women's stockings, it's in the upper right. I don't wear women's stockings. I am a huge fan. I don't wear them. Huge fan. So anyway, this problem of getting the colors right. See, if you're a guy like my dad, the rock hound, amateur geologist, are there any geologists here? There must be, yeah. You'll recognize these people. They just walk around looking at the ground. Pick up a rock. But it's not just a rock, it's another rock. And you go to their dorm room or their house, where it's just rocks. Their garage full of rocks. Like, this one's different, see? I see it, I don't know, but look! Yeah, okay. Because when they look at the color of the rocks, the geologists get a very good idea as a first cut of what's in the rock, or especially what's on the rind, what's on the outside of the rock, like the rind of an orange. All right. So they want to get the colors right, and the reason Mars is the taupe ecru, burnt orange salmon stocking thing, mocha, is because it's rusty. The whole place is covered with iron oxide. So, to combat this problem, back in the 1990s, Governor Huntsman made reference to Kurt Cobain last night. During that time, they were going to send the Sojourner rover to Mars, and so they had one of these there on it. And I was at a meeting at Cornell University, and they had this thing there. And I said, "What is this thing that you have?" "Oh, Bill, that's That's photometric calibration target, that's what that is. Photometric calibration, yeah. So, like, what do we do with such a, it's the test pattern. So they point the camera at the photometric calibration target, and they look at the color coupons, you might see around the edge, and they look at the color of the shadow. Now the shadow here was taken in an oven, the picture rather was taken in an oven, lit by incandescent, or that sort of light, like these lights, and it's quite yellowish. So far, we did not have a word for yellowish, but I have stepped up, and I have coined xanthescence. Xanthescence. Yellow. So if you look at my shirt, if I make a shadow, like with your finger or a pen or your friend's head, whatever you've got, you will see that the shadow here is quite yellow, although there's some going on blueness, but yeah, it's yellow. Well, in this oven, this test picture in the oven, it's quite yellow. And so we had a bunch of engineering drawings out of these big tables, and I was looking at this thing, looking at this picture, looking at this deal. So it's this big. It's the palm of your hand, 80 millimeters by 80 millimeters. And it has a metal stick sticking up. And I worked at Boeing on 747s. I don't want to shock you, I was very well supervised. There is a tube like about this long, hydraulic tube on 747, still flying, that I kind of think of as my tube. It took me 3 years to convince my boss and his people that we needed this tube. And the reason it took so long is it added weight to the airplane. You're never supposed to add weight as evil. You're fired. You're adding weight. No, the tube, the resonance, the vibration. So they went along with it. Well, I'm looking at this metal stick, and they told me it's going to cast a shadow on this. And I'm like, you guys, aren't there a lot of things that cast shadows? Aren't there wires and bolt heads? But then wait a second. We've got to make the photometric calibration target into a sundial. I appreciate the applause, but let me tell you, you heard the hesitation. Yeah. So in this meeting, they're all like, what are they like? They're all questioning me. You know, Bill, Mr. Nye, it's Mr. Nye, right? I mean, because we all have PhDs. Anyway, Bill, Mr. Nye, we don't tell time with sundials. This is the space program. Dude, Bill, I see you're wearing a watch. No, we can reckon time on another world. It'll be cool. It'll be like those people who speak Klingon. But it'll be real. So the head guy, Steve Squires, principal investigator, Jim Bell, they thought about it for a couple of days and went, okay. So you guys, there are 2 sundials on Mars. Show you, this is Husband Hill, named after one of the guys killed in the Columbia wreck. But there's the Mars dial, down in the corner. For those of you over here, it's down in the corner there. They're really very compelling. It's really changed your life. Anyway, these things are this big, and we did use them. There are tens of thousands of pictures of them, because they are used to calibrate the camera every day, every sol. On Mars. Sol is a term coined back in the disco era for a day on Mars. And here's what they look like. Here's one up close. Now at NASA, nothing is out of focus, because that would be a mistake. This is defocused. Defocused. The problem is it's too close to the camera, so it's not inherently out of focus a little bit. Now if you look at this picture, and you have to take people's words for it. Down there in the shadow, I think you can see the little orange tinge We did not have a word for this. So now we have Orange d'essence. Tinge of orange. Now, if my father were here, he would tell you, sundials should have a motto, right? They should give you something to think about. And it's no trouble at all to find sundials that say, I only count the sunny hours, or life is but a shadow. And one of the guys who worked on this at the University of Washington, Woody Sullivan, is quite an astronomer and quite the mnemonicist. The thing that sticks up on a sundial is called the gnomon. Oh, and what I brought to the party, taxpayers and voters, I wasn't the first guy to suggest that we make this photometric calibration target into a sundial, but as near as I can tell, I was the first guy to realize that when you're near the equator, you don't want a triangle sticking up. You want a symmetrical thing. My dad was all over this when he was in the tropics. Like you'll go to Hawaii, you'll see a rectangle or just a stick of what in English we call a noon pole. That's what my dad used with a shovel handle. So when you're near the tropics, the sun is to the south of you sometimes and to the north of you other times. Anyway, Woody Sullivan knows this sundial in France, and it's the key word is blessant. So it's anyway. Every hour, this is on a sundial. Every hour injures. Yeah. The last hour kills. Oh, it's a sunny day! It's great! Oh God, that's that whole, commune and the strain of existentialism, life sucks and then you die. Oh, that's great. The last one kills, oh boy. Well, on our Mars dials, as we call them, there is a motto. Our motto is 2 worlds, 1 sun. Kind of cool. The guy who came up with that is Lee Friedman, the guy I now, who's retired, I've now replaced him. But that aside, it's kind of cool. And I hope you take a moment and realize that shadows on this other world must needs be cast by light from the same life-giving star as the shadows on Earth. That's quite a little thing. And the other thing I want to tell you, taxpayers and voters, I did the vibration analysis on the gnomon, the metal stick. And it's indestructible. You could pull a truck with it. But if it had come loose, and banged around on the electronics, it would have been very bad for Bill and everybody. Anyway, with that said, it's fine. But I did do that analysis. And then somebody sent me this picture. For those who can't see, the gnomon is knocked over, presumably by the Martian wind. But just whoever did it, I want you to know that you got me. There was a full, sort of comedy beat, like, ha, ha, ha. And I realized it was April Fool's Day. Oh, you hilarious kids with your Photoshop, you're just... Oh, boy. You got me, you got me. Anyway, this is another picture from way back in the Viking days with the colors now correct. The air on Mars is not even 1% of the atmospheric pressure of the air on Earth. The air on Earth, we used to say, is 1,013 millibars, 1,000 millibars. Well, on Mars, it's only 7 millibars, less than 1%. And millibar, a great unit, but it's not in the System International. System International. Because it has a 10 to the 5th in it. It doesn't go on 10 to the 3rd, 10 to the 6th. It doesn't go 1,000 million, it's 100,000. So now the official unit is no longer a millibar, it's a hectopascal. 7 hectopascals, okay. Maybe, here's my proposal, people, we change it and call it 7 heps. 1013 heps. All right, these are data from, not from Viking, but from Sojourner in the sort of the height of Nirvana and smells like teen spirit and stuff. So, on Mars, the atmosphere is 95% carbon dioxide. On the Earth, when these data were taken in the mid-1990s, is 0.03% carbon dioxide. So just notice that 0.03%. It's not much. That's the same as 300 parts per million. Doesn't sound like much, parts per million. Everything you eat comes from plants, which make their living on 300 parts per million. Without this tiny amount of this unusual or common gas, you would not be able to live. All of you were alive. Well, almost all of you were alive when this number, rounded to one digit, changed from 0.03 to 0.04. Used to be 315 parts per million, now it's over 390 parts per million in your lifetime. And this tiny change, and what seems like a small number, is going to, dare I say it, change the world! Now, here I am. Well, actually, this is a picture of me. I'm here. A picture of me on the rim of Mount St. Helens, the crater of a volcano in Washington State in North America that blew up in your parents' lifetime in 1980. It really exploded. And we're all lying down because that's the rim of the crater. I mean, right there is 1,000 feet straight down. And plus, this, what people call volcanic ash, the Scandinavian word is scree, it's just like ball bearings. I mean, when you're standing there, it's like, whoa, you're like the guy in the Roadrunner cartoon, whoa. And so everybody's lying down and just sort of creeping up to the edge. But from this vantage point, Mount St. Helens, one of the volcanoes in the Pacific Northwest. Remember presidents of the United States of America that she's going to blow a volcano? There are a whole string of volcanoes up there. And this is Mount Rainier. Oh, it's a picture of Mount Rainier. Mount Rainier, I'm pretty sure, yeah, it would not fit in here. It's 14,000 and something feet. So, just look at this picture carefully. This picture, and you'll see a layer of smog. And I'll point it out to you a little better. There's this layer of smog. So many times when you're in a place like the Pacific Northwest, hiking around, you think you're in the wilderness, you're in the middle of nowhere. Well, the smog sloshes in from Portland, Oregon, and Seattle into this basin, and it sits there all the time, just like the inversion layer here. And this is a result of human activity. There's no other way for the smog to get there. That's people doing it. And that's the stuff that you can see. There's a lot of other gases introduced that you can't see. So volcanoes turn out to be an interesting part of the story of our understanding of climate change. This is a map of the world with a timeline. So as we go along the map, from left to right, along the timeline from left to right, every time there's a volcano, it's noted, a big volcano. So Krakatoa was this huge thing in the 1880s. And it blew up and threw so much stuff into the atmosphere, it reflected sunlight back into space, the Earth cooled off a little. And the same thing happened in Santa Maria before World War I. Then there's a couple more big ones, opportunities coming along. And you'll see that even though the Earth cools off whenever there's a volcano, steadily the temperature of the world is getting warmer. Now these data are taken in such a way that people do all they can to correct for errors. So these are almost all from the ice. You take the ice from Antarctica or Greenland, and or Kamchatka Peninsula and Siberia, and you count neutrons with your mass spectrometer, like you have in your car. And you can see that when the sea surface is warm, more lightweight atoms, especially oxygen, are evaporated. And then when the snow falls, it has the lightweight oxygen in it. And so you can correlate the temperature of the sea with the number of neutrons with the temperature of the world. And then the volcanoes, every time there's a big one, it shows up in the ice record. And by the way, St. Helens didn't affect the world's temperature much at all because it's not in the tropics. If you're a volcano and you want to affect the world's climate, you really should move to the tropics. If that's something you want to do as a volcano. But then you see, using these data, the world's is projected to get warmer and warmer and warmer. And this is what people at the Intergovernmental Panel on Climate Change from the United Nations, this is what the scientists do. They correlate these data every which way, and the volcano thing really is striking. It shows a cooling of the world, and it happens to correlate historically exactly with a big volcano in the tropics. It's quite a thing. So the last 10 years were the warmest 10 years on record. And by the time, let's say by Halloween, people will have been able to show that last year was the 11th of the 11 warmest years on record. So the world's warmed up about more than ½ degree Celsius. And that doesn't sound like much. 2 degrees Fahrenheit or 1.5 degrees Fahrenheit doesn't sound like much. But if you think of the Earth as this big disk in space, 13,000 kilometers across, and you want to warm it up ½ degree or 1 point something degrees Fahrenheit, it takes a lot of heat to do that, a lot of energy. And we are doing that. And the reason we are able to do this, albeit by accident, is because if we look at the Earth from space, you can really see a striking phenomenon. This is the International Space Station. I put once again a picture. But when you look at the Earth edge on, it almost looks like it's out of focus, like it's defocused or something. But what's really going on is that the atmosphere is so fantastically thin compared to the Earth. We all run around in the atmosphere, flying kites, breathing air, flying airplanes, all the stuff we do. But the atmosphere is just so thin that we, as a species, have been able to affect its composition. So this is what I like to call an appreciation for your place in space. If everybody, I claim that if everybody realized how thin the atmosphere is, we would be making different decisions about the world. When I was a kid, we went to the World's Fair, and there was a display showing the world's population. It just had changed. My father was very disappointed. It changed from 2,999,999,999 people on Earth to 3 billion. We had just missed that. I mean, this is the guy that took pictures of his odometer on the car as it changed to 100,000. The cop pulls him over and says, "Sir, what are you doing? I'm taking pictures." Okay, really. It's a highway, please. Anyway, it was 3 billion when I was 9 years old. Now, as of last night, it was 6.86 billion. And by the end of October, you guys, it is predicted there will be over 7 billion people in the world. 7 billion people. And those two things, the astonishing thinness of the atmosphere combined with 7 billion people, that's how we are able to change the world's climate. And this is going to be the biggest challenge for you guys. You will have to, dare I say it, change the world. Now, people are going to come to you in the next few years with kooky ideas. And you are going to have to, as taxpayers and voters, whether you choose the great worship calling of becoming an engineer, or physics major, or chemist, or biologist, or something civilized, or if you become a venture capitalist, or an attorney, or a historian, or a French literature major, whatever it is, you are going to have to make decisions about whose ideas are the kookiest. People are going to say, let's put big reflectors in space. That'll be easy and inexpensive. Oh, I got it. Let's spew the same stuff that comes out of volcanoes sulfur dioxide, which rains as sulfuric acid. Well, spew that into space, up into the atmosphere. It will reflect sunlight. And then it'll rain acid a little bit. No big deal. Okay, let's fertilize the oceans so that the plankton in the ocean soak up more carbon dioxide with green plants. We'll turn the whole sea into a giant ocean-sized pond scum. Great, that's going to be great. You see, some of these ideas are probably not that good. Here's one that I find quite intriguing. If you look at this motorboat, you see the motorboat? If you look, look at this motorboat, the bubbles behind it are white, right? And they're reflecting light back into space. Well, way behind the motorboat, the white bubbles get less and less white. Now, this is in a lagoon in Belize. It's very deep, very cool place. Anyway, these bubbles, when they get really small, stay dissolved in the water, but you can hardly see them with your eye. And so these guys have done some sort of traditional physics with them. And you have to have two samples. Like you have to have the one without the bubbles and the one with the bubbles. And this one reflects light and this one doesn't. And so it may be that something like the World Bubble Council will control the bubble makers on the back of ships to reflect sunlight. I mean, it's an idea so crazy. It just might work. But it'll be up to you all to figure out whether or not it's a dumb idea. So here am I. Well, I'm here on the roof of my house. Right on. I have 4 kilowatts of solar panels. I have a solar hot water system there in the foreground, which, by the way, you guys, is just plumbing. The heat is free. Like, you don't have to pay. It gets hot while you're on the roof, or not. I mean, who's better at plumbing than the United States? I mean, who? Holland? I don't know. I want one of you to go into the solar hot water business, okay? So that you will get, dare I say it, rich! Then I have a dome. You see the dome there? That takes sunlight down into the house even when the sun is low in the sky. That bright disk is the light coming into the room below. And it's been 5 years, I still go in there and try to turn the lights on. It's so crazy bright. But these are all existing technologies. You know, my watch is solar powered. And these solar panels are about 10% efficient. Satellite solar panels are almost 30% efficient. What if they were 50% efficient, or 60 or 80% efficient? If you could make those solar panels, my friends, you would get rich. Woo! Crazy rich. Yeah. Bill Gates, the head of IKEA, rich. When I delivered the Washington Post in Washington, D.C., Ripley's Believe It or Not would, from time to time, run this story. I was a little kid. Insects, which have been flying for 350 million years, defy the laws of aerodynamics. And the bumblebee, which is, well, considering its size and shape, is an aerodynamic misfit and should be unable to fly. Now, even as a little kid, I went out and I looked at bees. And if they are violating the laws of aerodynamics, nobody is going to give them a ticket. Even as a kid, I realized the problem is not with the bees. The problem was with the theory. The theory's what's screwed up, not the bees. And yet people ran around going, oh, they shouldn't be able to fly. Which is actually kind of a cool question. And it was during your lifetime, really, that people figured out how bees, Hymenoptera, 4-winged flies, are able to have these little halteres, little extra wings that create these cool little whirlpools, vortices, and helps the downstroke a lot. And then their bodies are like springs. They pull them tight and let them, their thorax, I can't do it myself. And their wings flap 40 or 50 times for each thorax pull. And that's why, if you're a bee, by the way, you wear out. The worker bees are all girl bees. Yeah, coincidence, yeah. And they wear out after a while, and they seem to accept it. Anyway, I guarantee you, there are things that you are absolutely sure of. We are certain of. Just like the aerodynamic theory and the bees and Ripley's, believe it or not. Things that we are sure of that are absolutely wrong. I guarantee you. So, you don't have to take my word for it. You'll see. And I'm no different. I'm sure of stuff that's absolutely wrong. So, I lived in Seattle for a long time. And there's a local hero, a guy named Tex Johnston, who was a fighter pilot in World War II, and he affected that right stuff kind of thing. Hey, I'm going to fly this here airliner, and I'm going to bring it in, and I'm going to do. So the guy did a barrel roll. He did a roll with an airliner. Now I don't know how many airliners you've been on, but we don't do that. We don't roll them over. This is not a toy. This is like, thing is heavy. So we flew the thing in a roll, and in those days there were 3 people in the cockpit. There was a pilot, co-pilot. It was before the term captain and first officer sort of caught on. Pilot, co-pilot, and engineer. And the engineer got out of his chair somehow and took this picture, and the whole world, the plane is upside down. And in Seattle, this was at Boeing, it was a famous or infamous, notorious picture. And so he lands the plane, and everybody comes up to him, you know, Tex, what are you doing? And at first he said, I'm selling airplanes. This is Boeing's big chance. And then he said, one test is worth 1,000 expert opinions. And that's pretty cool, my friends. When people, especially grown-ups, adults, tell you that you ought to do something, just keep in mind that those adults may be absolutely wrong. One test is worth 1,000. Not wrong about everything. But texting and driving, and avoid that. So nowadays, I have a day job. I'm executive director of the Planetary Society. And this is a picture of a rock that came from Mars. We study its isotopes. We take it to Huntsville, Alabama, and crack it open in a little vacuum chamber with these stainless steel rock crack openizers. Tiny bubbles of gas come out that are exactly the Martian atmosphere. So this rock apparently got knocked into space 3 billion years ago, found its way to the Earth, and landed in, this one landed in India. And people picked it up and, wow, it's a rock from Mars. So people have speculated that if a rock can make the trip from Mars to here, and some other meteorites that people find have amino acids in them, like complicated biology chemicals in them, is it possible that life traveled from Mars to the Earth 3 billion years ago, and we are all really Martians? It is an idea so crazy that it might be true. So at the Planetary Society, we have rigged up this kooky little thing. People, 40,000 members have sent us money from around the world, 130 countries, and we built this little titanium hockey puck. And in there we have some very well characterized bacteria, and we have the happy tardigrades, the water bears. You need a magnifying glass, like 5 power, 10 power, and you can see in moss. You see a happy little water, but they move very slowly. They're water bears. We packed them in this thing, and we're going to send them to Mars and back. And if you guys choose to send us enough money, we will send you a little plush toy. Very happy. Everybody in the scientific community, the astrobiological community, they're all pretty sure that microbes will be fine. They should be okay in the cold. The cold of deep space shouldn't be an issue. But no one knows if the radiation will get them. Will it kill them? Will they mutate? What will happen? So one test is worth 1,000 expert opinions. And I spoke to the planetary protection officer at NASA. This is somebody responsible for keeping us from violating the prime directive, contaminating another world. Yes, the prime directive, this. And she said, oh, you don't even need to run that test. That's going to be fine. You don't even need to do that. That's going to be, they're going to be fine. And that's when I realized it's a good idea. Because they just hadn't thought of it. So we're putting this thing on a Russian rocket, which is going to Phobos, the moon of Mars. And the Russian, former Soviet Union used to have a cool space program. They used to do amazing stuff. And now, indeed, when you want to go to the International Space Station, you go there on a Russian rocket. It's sort of the same technology from 30 years ago. And it's reliable, but we'll see if we can pull it off. So check in. Leaves in November. You can only go to Mars every 26 months or so because of the orbit. So leaves in November, and we'll see if in 3 years we'll see what happens. Stay tuned. And if you want, we'll send you a plush toy water bear. The Pioneer spacecraft left the Earth in winter of 72, 73. Oh, 73, 70. Wait, 73. Let's just go 70. And there are two of them. One went north out of the solar system. The other went east and west. East and west changing as the Earth goes around the sun. And these are the famous first spacecraft to have a plaque on them. And you guys weren't around for this, but there was all this controversy. Any alien could figure this out. I mean, up there at the top is obviously a representation of a hydrogen atom, and you obviously measure its resonance in binary numbers, and then you easily show that the pulsars that have the binary numbers are depicted along these straight lines. Anybody can figure it out. There's nothing to it. What? Anyway, then it had two pictures of two humans. And there was all this, you are sending pornography into space. Really, I think it's going to be okay. I'm not sure there's any entity that's going to be upset discovering that you could scratch somebody, a guy from Europe on the thing. Really. But these things are of great significance because they're not as far from the Earth as everybody thought they should be. They're a little closer to the Earth by about 400,000 kilometers, which is a long way. But they've been traveling for almost 40 years. So people were wondering what is going on. And there was a lot of controversy in the scientific community. Maybe there's this new physics. Maybe there's some spooky interstellar something that's holding them back. Keeping them from traveling. But the other thing is the one that's going north is the same closeness as the one that's going east and west. So if there's some ether or something in space, you might expect them to be different, but they're the same. Anyway, everybody's pretty sure now that it's just heat, it's heat given off by the radioactive battery, the radiothermal electric generator. And this photon pressure going off the front is slowing them down a little bit. And the other thing that they were just able to determine is the force is not toward the sun, which people speculated, it's actually toward the Earth. And understand over the last 40 years, the Earth's going around the sun, so it's a heck of a bit of mathematics to figure that out. And at the Planetary Society, we got people around the world interested in this problem, and we saved the tapes, these old computer recording tapes, where the data were stored, and now everybody's pretty sure it's just photon pressure. But there may be another mystery like this, or anomaly, where there really is a new physics, and the world really is going to change. And this thing is pretty much settled, but not all the way settled. Now, it may surprise you to learn that heat going off the front of a spacecraft can slow it down, but it can. This is the Planetary Society's other crazy project. This is a solar sail. This is a spacecraft that will be pushed through space by the sun. Hold it, what about rockets? Well, we'll start with it. Get in Earth's orbit, and then sunlight will push this spacecraft along. And you say, wait a minute, I thought light had photons. Photons have no mass. How can they possibly have momentum? Very good, thank you. But you can look at this way, you're college students. E equals mc squared. Who doesn't love that? Now let's divide both sides by the speed of light, c. So E over c equals mc, which is like mass times velocity, which is like an expression for momentum. People. This could be the way that we do our space exploration in the future, where we have a spacecraft that has such a big sail, it can stay in orbit around the sun without falling in, and we can monitor the magnetic storms on the sun. And maybe we could build one big enough to go to Pluto in less than 6 years, instead of twice that, or 2.5 times that. It could be really cool. If you guys choose to support the Planetary Society, we'll set you up. We'll get you included in the solar sail mission. This is the periodic table, and it has a lot of elements. And you all know it. You've heard of it. Iron, titanium, oxygen, carbon, without nitrogen, sulfur, phosphorus. But most of the universe, on a scale that's really hard to get, is either hydrogen or helium. It's 90% hydrogen, 8% helium. Then everything else, the stuff that we're all familiar with, the stuff we're made of, except for hydrogen and water, is what I like to call everything else. And it is in the everything else that you guys are going to make discoveries that are going to, dare I say it, change the world. When my grandfather went into World War I, he put a gas mask on himself, and he put a gas mask on his horse. Because that's the way people did things. When there was a fire on Birtwood Place in Baltimore, Maryland, the fire truck showed up pulled by horses. I mean, that's how they rolled, if I may. But 20 years later, nobody did anything like that on a horse. Everything changed in just 20 years. Like that. Because the acceptance, the invention, the perfection, the great increase in reliability of the gasoline engine. When I was a kid, a guy named Gil Scott Heron, who died earlier this summer, had a huge hit with a song called "The Revolution Will Not Be Televised." The revolution will not be televised, meaning the man, the government, will not be able to control the media and put whatever the government wants on the television. And that turned out not to quite be true literally. It turns out the revolution doesn't count unless it is televised, unless it's on Twitter or Facebook. There was no revolution. I didn't get a tweet about that. No, really. We've turned over governments in the Arab world. Things are changing at an astonishing rate because of the speed with which you guys can share information. The internet has changed the world, and it's just the beginning. You guys are going to be able to share information with colleagues all over the world at the speed of light. Next time you're on Mars, and you walk up to one of the 2 rovers that are there now, or the Curiosity rover, which leaves in November and arrives next August, go up to one of the Mars dials, and in very small writing is the first message to the future since the pioneer days. It says, we built this spacecraft in our year, this will say 2011, it arrived here in 2012. We built these instruments to look for signs of water and life, to learn about Mars' past, prepare for our future. And then it says, in very small letters, it says, to those who visit here, we wish a safe journey and the joy of discovery. My friends, that is the essence of science. That is the essence of this enterprise, is to know our place in space, to what Carl Sagan, my old professor, called the joy of knowing. That is what science is all about. That's what brings out the best in us. You are just at the start of your careers as taxpayers and voters and world leaders and changers of the worlders. This is what it's all about. The joy of discovery. This is how you are going to, dare I say it, change the world. Actually, it's a picture of Saturn. Taken almost 2 years ago by the Cassini spacecraft. your colleagues, scientists and engineers, got this spacecraft out beyond the orbit of Saturn, pointed it back toward the sun. You can see the sun just glimmering around there, sort of the 7 o'clock position. And there it is, the only night on Saturn with the shadow of the rings. By the way, if you had a bathtub big enough and some extraordinary source of gravity, Saturn would float. Ooh, a little weird. But this is not just a picture of Saturn. This is also a picture of the Earth. The Earth is right there. And if you get a high-resolution version of this, you can see the moon. And so now, if we go over there, a few thousand kilometers, a few thousand miles, and leave the camera open a long time, there's the Earth against the background stars. And I hope you get a sense that that's it. There is, as Professor Sagan used to say, no cavalry coming over the hill. This is it. This is where we make our stand. Everybody who's ever lived, everything, every sea jelly, every oak tree, every cactus, everything, every strawberry has made its whole living on that little pale blue dot. And so it is up to us, my friends, to take care of the world. It is up to you to change things and leave the world better than you found it. When I was in 3rd grade, Mrs. Cochran told us that there are more stars in the sky than grains of sand on the beach. And I remember thinking, Mrs. Cochran, really? I wouldn't have expressed it this way. Mrs. Cochran, really, are you high? What? Have you ever been to a beach, lady? There's a lot of sand, okay? Left and right, there's sand. Thousands of nautical miles of sand. You shuffle your feet and there's sand. The tide goes out, there's more sand. Grains of sand. Lady, really? Well, apparently there are more stars than all of that. It's astonishing. So I'm a kid standing on the beach and I think about going out deep sea fishing with my uncles, and you can't see the land anymore. 17 nautical miles, or whatever it is. So I'm just like the speck on a boat that's really no different from the sand, the grains, the sand. I'm just like a speck with the specks. And the Earth is just another speck. The sun, completely unremarkable star, nothing special about it. I'm a speck on a speck, which orbits a speck, with a bunch of other specks in the middle of specklessness. I suck! But my brain, which is only this big, in the case of my old boss, of course, much smaller, but with your brain, you can imagine all of this. With your brain, you can know your place in space. And with your brain, you can, dare I say it, change the world! Thank you all very much.